So thank you very much for the nice introduction, and I'm glad to be here. I have a talk from Rolf Reiter. He cannot be here today, so I have the pleasure to be on your very nice Colloquium here and this wonderful scenery. And I'm going to talk to tell you a little about a special type of rubber modification. As mentioned before, I'm not a member of CTS Bitumen. I'm from a German company. We are running 6 asphalt plants. We have some quarries. We make quite a lot of road constructions. We have 7 paving troops, and in a few days we'll have finished a plant for producing polymer modified bitumen. Despite that, we made quite a lot of testing with these CTS products. So I'm going to tell you from the view of the practice some things about these these products. So I'll give you a short overview about the content of my talk. So I'm going to tell you something about the history of rubber modification. Then I want to tell you something about the state of the rubber modification in Bavaria. Bavaria is the region in Germany where rubber modification is most popular. They use it very much, and they have an old guideline. Specific the terms of delivery for rubber modified bitumens, and later I'm going to tell you how this works, how the products are produced, and what's typical for that and how they work. I'll show you some diagrams to show how the polymerization will work when I try to compare rubber modification and the modification with polymer modified bitumen on the basis of, let's say, mostly SBS. Then I'm going to talk about aging. Aging is not a very nice theme. Every morning when I go in the bathroom and look in the mirror, I see what aging is. It's terrible. So, but I'm not the only one who suffers on aging. It's also our bitumen and it's also our asphalt. So I'm not alone in the world fighting against aging. So then I'm going to talk about aging in practice and laboratory, dynamic coat behavior of rubber modified bitumens, about cohesion, and last but not least about the economic efficiency of those pavements. Okay, rubber modification is not new. If we want to go to the beginning, we have to move to the United States. In the early 70s in Arizona, the rubber modification started, and the reason is, a lot of you know how it looks like in Arizona from many movies. You have the Colorado Plateau, which is very high, at an elevation of about 2,000 meters. That means the climate is very continental. That means you have very high daytime temperatures. At night it gets very cold, and the winter time you have temperatures which might be minus 30 degrees. That means you have quite a lot of stress on the pavements, thermal stress on the pavements. And that led to a damage of the asphalt pavements after 5, 6 or 7 years. So the people there were not very satisfied with the low lifetime service of those pavements. So they started with a rubber modification. And it worked very well, and so with these good experiences, the technique moved around the United States, and it swept over the Atlantic Ocean to Europe in the early 80s. And the beginning was in Belgium and in France on the basis of a patent of Exxon. And to Germany and Austria, it moved in the middle of the 80s, and it was shown already at that time that the durability of those pavements were quite good, but other experience, the handling was sometimes terrible. So there was also a very specific type of pavements who had been done, especially the open porous pavements, but not more. At the end of the 90s, according to the World Exhibition in Hannover, large areas were paved with PAs, and most of them were rubber modified, and this worked very well. But a major important step was 2010, when the first regulation for rubber modified bitumens in Germany took place, the terms of delivery in Bavaria. Okay, where are we now? Okay, that's okay. Yeah. Oh, too fast. Okay. Okay. This is the use of rubber modification in Bavaria in 2018. The amount of the rubber modified bitumens is now between 25 and 30%. That's really quite a lot, and most of the bitumen goes in the stone mastics asphalt. Already about 40%, and 27% of the total mass goes into the porous asphalt. Some goes in the binder courses, and some in the binder layers, and some in asphalt concrete. From the porous asphalt, from these 27%, they represent 100% of all open porous asphalt in Bavaria, and also in Baden-Württemberg, 100% of all open porous asphalts are built with rubber modification. Next. Okay. Okay, so let's go to the guidelines of Bavaria, to the technical, to the terms of delivery for rubber modified bitumen. This rule book was published in 2010, and it was the first rule book in Germany which has exclusively described rubber modified binders. And these guidelines were on the basis that there should be an only approach to describe quality. Therefore, only those product groups were described in which extensive, positive as well as many years of experience could be reliably demonstrated. By introducing those rules, they were rise to the rule building. That means the quality of the modification was the focus of these papers. It was not the aim to bring every product of the market within the paper. But we have another guideline who has done it in this way, but this does not work very well. So they were very strict. And the regulations ensure that the optimum polymer digestion would meet all requirements, thereby achieving the expected asphalt performance. And so only two types of modifications were possible or fitted in within the TLRMB. One was hot liquid ready to use rubber modified bitumens, and what I'm talking today, rubber modified bituminous granules. So let's have a closer look to the production of those products. And the production is a so-called wet process. So that means you have a liquid bitumen and you add the rubber powder, and in a closed system, in a specific plant, at temperatures of more than 200 degrees under an inert gas atmosphere, this production takes place. And what's very important, you need to have a sufficient time for the reaction of the rubber powder with the bitumen matrix. And if this is fulfilled after, let's say, 2 or 3 hours, it depends, you can measure this, you start cooling down and you make the granulation process as a next step. And when you have the finished product, if you go to the asphalt plant, you have these granules, you add it via a dry dosage directly in the mixer of the asphalt plant together with the aggregates in the dry phase of mixing. After this, you add the bitumen, and you have a post-mixing time which is according in the same range like standard bitumen or normal polymer bitumen. And if you do like this, you fulfill the requirements of the GRM from Bavaria. So let me describe it with some schematic pictures. And on the left-hand side, you have the bitumen matrix and the rubber particles within the bitumen. This would be a situation directly after adding the rubber. And here you have a situation at a temperature of 170 degrees after 2 hours. And what you see, you have only a slight reaction with the bitumen matrix. And now on the right-hand side, you have the situation if you have elevated temperatures at more than 200 degrees, sufficient time, and so you have a perfect polymer mobilization within the matrix, and that's the target, that's the aim. How shall it be? Okay, what advantages have such bituminous granules? They are products with sufficient long-term experience and very high process reliability. Those products are on the market since 2005, so that means around 15 years. You can, to the asphalt, you also can add every viscosity modifying additives. There's no reglementation. Almost the storage is very, very easy. You can store it at long time. There is no loss in quality of the material. The delivery is easy. You can deliver it by truck, by train, by container, as big bags, or even have PE bags of 10 to 20 kilos, whatever you want. The use of recycling asphalt is no problem, and because the addition of the GRM is always calculated on the total binder content. And the produced asphalt can be used immediately after it leaves the asphalt plant. GRMs are finished products, and the responsibility for the quality of these products is at the producer and not at the mixing plant. So that's an advantage for the user. And you do not need any additional time in a silo or on a truck. So now the question is GRM and polymer modified bitumen, are they equivalent? In the foreword of the GLRMB is written that rubber modified binders can be used as an alternative to polymer modified binders. That means they are equivalent. The question is now, is this statement true? And now you have some sheet which shows you the lifetime of open porous asphalt in Bavaria. On the left-hand side you have the average service life of PA8 with a high modified polymer bitumen. It's around 8 or 9 years. Not more. The longest known service life of an open porous asphalt with polymer bitumen is around 10 years. On the right-hand side, you see the result with rubber modified binders. The average service lifetime from a PA with rubber modification is around 15 years, and the longest known service lifetime is around 19 years. So that's much more, though the answer in this case is that polymer modified bitumen is for sure speaking. So we talked about aging, the domain. This is a domain of rubber modified binders. This is a low aging tendency. These binders have a very high viscosity that leads to very thick binder films which protect very well the aggregates. And special properties or what supports the quality of the binder is a special nature of the rubber, the ingredients which are in the rubber. And CTS only uses specific rubbers, only rubbers from truck tires. And the composition plays a major role for the quality. It's not sure what is, but I think, or most people think, it's also the soot which is in the rubber, or there are some antioxidants, that the tendency of aging is reduced significantly. Okay, what advantages do you have? You have much higher durability, you have longer service lives, you have reduced maintenance costs, you have extended renewable intervals, and last but not least, you have a much higher economic efficiency. If you now go in practice and look at the agents, there were some test tracks on the motorway A5 in Germany, and they observed this over a period of 10 years. And what you see, the different aging behavior of different bitumens. On the left-hand side, it was a standard normal paving grade bitumen, like a 50-70 or so, and what you see, you have an increase in ring and ball values of 2 degrees per year. That means in 10 years plus 20 degrees in the ring and ball value. And using polymer modified bitumen, those values decrease a little. You have maybe 1.5 or so, so you have 15 plus of 15 degrees, but after rubber modification it's quite less. It's around only 10 degrees. And later in Bavaria they have made some more statistics, some more measurements, and what they can say for PAs, for open porous asphalt, you have an average an increase in the ring and ball value between 0.7 and 1 degrees per year. And if you ever look at stone mastics asphalt, it's only 0.1 to 0.3. That means the aging tendency is quite low. And Dr. Schmalz from an institute in Regensdorf, it's a very well-known laboratory in Germany. He made quite a lot of investigations, and he came to the conclusion that rubber-modified bitumen's age is about 70% slower than unmodified bitumens do, and about 40 to 50% slower than polymer-modified bitumens do. And they have a better cold behavior than PMB, and the properties reduce also the tendency of the asphalt against high loads, against frost, de-icing salts, and temperature changes, even at low winter temperatures. So altogether, there's also a very low tendency of superficial grain loss and crack formation. This is not much described with those products. From Dr. Gogolin and another investigation about aging showed a similar view. A short use with the RTFOT, short-term aging, you do not see this much. But if you now have a look at long-term aging, you see the big difference between a standard bitumen, PMB, and rubber modified bitumens, and altogether you have a tendency which shows you as aging decreases with increasing degree of rubber modification. Having a look to the dynamic cold behavior, there had been some tests on the PMB and the rubber modified bitumen with at minus 15 degrees. So you have the polymer bitumens show the crack at around 200 cycles of this method, and rubber modified bitumens finally after 1,000. So also you see it's quite a good low temperature behavior. Okay, let's come to the point cohesion. All projects where you have high shear forces and where you have expected probably a big risk of grain loss, for instance, roundabouts and crossing areas, industrial areas with forklift use, climatically exposed locations, bands, or road with rough winter service, they can benefit by using those binders very well. So if you have a strong need for high adhesive strength, especially in roundabouts, so you can vary also in the concentration what kind of rubber modification you choose. A standard modification normally has an amount of a GRM of 12%. This is a medium concentration of 22%. And if you are producing an open porous asphalt, it goes up to more than 30% of this product which is used within the asphalt. So let's come to the economic efficiency. In case of open pore and pavement, there is much evidence that the service life increases approximately 50%. You saw this on the slides before compared to PMB, and these are weighty arguments to a major step to sustainability. You have longer life services, you have reduced maintenance costs, and you have extended renewable intervals. And before the background of our carbon footprint, is it really important if a road construction leads to a longer lifetime of 20, 30, or 50%. So that's a mighty argument for our industry and for the carbon footprint and for the emissions we have. So I come to the conclusions. According to the TLRMB asphalts, and you can have quite a lot of different recipes from thin layer pavements to binder course pavements. Millions of square meters have been paved in Germany, or not only in Germany, also in France, in Spain, in Croatia, or in Czechia. All are characterized by very high durability. Rubber modification has a high number of advantages in comparison to PMB and the standard bitumen. The aging behavior is excellent. The high viscosity enables to very thick binder films which protect the aggregates and have a positive effect on the durability. Because of those high viscosity and the thick binder films, you do not need any fibers in the PA or in the SMA. It's because you have no runoff of the bitumen of the aggregates. The storage in the asphalt plant is uncritical. You can use small amounts, small quantities, and you can process on the mixing plants. a few tons if you like. It's not necessary to order to buy large quantities. Normally, if we buy bitumens like PMB or standard bitumens, we always need a whole truck. So you can also make some smaller projects with that type of modification. Rubber modified bitumens have proven to have a serious economic advantage compared to conventional bitumen, especially in the porous asphalts. The high level of cohesion enables those asphalts for successful implementation for special asphalt concepts, and the reuse is possible and without any problems. So at the end, thank you very much.
Gospod Heppenheimer, hvala za izčrpno predstavitev. Verjamem, da je to tehnologija, ki ima vsekakor veliko prihodnost že zaradi same trajnostne naravnanosti, bo pa verjetno treba še precej dela na tem področju, tudi da bomo pač določene postopke vpeljali v proizvodnjo.